They devour everything that comes too close. Light, matter. Even time itself seems to vanish within them. Black holes are among the most fascinating and terrifying objects in the universe. But what exactly are they? Where do they come from? And could they, one day, consume us as well? Today, we dive into the mystery of black holes. A black hole is a region in space where gravity is so strong that nothing, not even light, can escape. It's as if space itself is collapsing in on itself. But how does such a cosmic monster come into existence? Most of the time, it's the remnants of massive stars. When a star with enough mass burns through its fuel, there is no longer any force counteracting its own gravity. It collapses, becoming denser and denser. In the end, only a single point of infinite density remains, the so-called singularity, and around it, an invisible cage, the event horizon, a boundary we cannot see beyond. Because from this point onward, gravity is so strong that even light can no longer escape. That's why a black hole appears, well, black. But what happens beyond this boundary? That remains one of the greatest mysteries of the universe. The event horizon is the boundary of a black hole. Anything that crosses it is irrevocably lost. But what exactly happens at this boundary? Imagine falling into a black hole. From an outside perspective, you would appear to slow down the closer you get to the event horizon. Your image would become increasingly distorted, as if time itself were stretching. To an observer watching from afar, you would never actually cross the horizon. You would seem frozen in time, stuck at the edge. But from your own perspective, as the person falling in, the experience would be entirely different. You would cross the event horizon in mere fractions of a second, faster than you ever thought possible. There would be no pause, no turning back. You would vanish beyond the horizon, with no way of knowing what awaits you. What happens to you beyond this boundary? Gravity becomes so unimaginably strong that even time itself is warped. Everything you know would change in ways no one can fully describe, and what exactly lies within the singularity remains one of science's greatest mysteries. But one thing is certain: the event horizon marks the point beyond which we have no control. The gravity of a black hole is so extreme that it can tear entire stars apart. This process is known as tidal forces. Tidal forces arise due to the immense differences in gravity acting on different parts of an object. Imagine a planet or a star approaching a black hole. As it gets closer, the gravitational pull on the side facing the black hole becomes much stronger than on the far side. These massive differences in gravity stretch the object apart. Tidal forces don't just elongate it, they completely rip it to pieces. So if you were to fall into a black hole, you wouldn't simply be pulled in. Instead, your body would be stretched to an extreme degree, as if it were being pulled like a rubber band. Scientists have given this phenomenon a humorous yet fitting name: spaghettification. Yes, you heard that right. Falling into a black hole would literally turn you into a cosmic spaghetti noodle. Your feet and head would experience different gravitational pulls, stretching you infinitely, a fascinating yet terrifying thought. These immense forces are one of the most extreme and astonishing aspects of black holes. They not only demonstrate the incredible power of these cosmic objects, but also reveal how they push the fundamental laws of physics to their limits. But black holes don't just consume everything near them. They are also capable of launching gigantic energy beams into space at unimaginable speeds. These so-called jets are another fascinating phenomenon associated with black holes. Imagine matter being pulled into a black hole, but not everything simply vanishes into the singularity. Some of the matter is accelerated by the immense rotational motion of the black hole and heated to such extreme temperatures that it turns into plasma, an extremely hot, ionized form of matter. This hot plasma is then ejected from the black hole in the form of massive, concentrated beams traveling at nearly the speed of light. These jets are not only stunning, but they are also incredibly energy-rich, capable of reaching millions of light years into space. Now, imagine the tremendous amount of energy being released here. These jets are so powerful that they can even influence entire galaxies. They can stop or alter star formation in the affected regions and shape the structure of galaxies over vast distances. So, a black hole is not just a cosmic vacuum cleaner, but also a colossal source of immense energies that have an impact far beyond its immediate vicinity. But how big can black holes actually get? The answer is impressive and almost unimaginable. The largest known black hole, called TON 618, it has a mass of an astonishing 66 billion suns. To put it into perspective, the supermassive black hole at the center of our Milky Way, Sagittarius A, only has about 4 million solar masses. So, TON 618 is more than 16,000 times more massive. This gigantic black hole is a quasar, an active, supermassive black hole that emits incredible amounts of energy. It shines brighter than entire galaxies because the matter falling into it is heated to extreme temperatures and emits intense radiation. If TON 618 were placed in our solar system, its event horizon would be so large that it would extend far beyond Pluto's orbit, a colossal, all-encompassing darkness that could consume our entire solar system. It is one of the most extreme objects we know in the universe, a true monster of gravity. Black holes are not just destructive monsters. They play a crucial role in the structure of the universe. They are much more than cosmic vacuums that swallow everything that gets too close. In fact, they are essential building blocks for galaxy formation. At the center of nearly every large galaxy lies a supermassive black hole. These colossal gravitational centers attract stars, gas, and dust, but they also keep them in a stable orbit. Without them, many galaxies wouldn't take the shape we observe today. Our own Milky Way has such a black hole at its center, Sagittarius A. It may seem quieter than active quasars like TON 618, but its gravitational pull keeps billions of stars in motion. Without this black hole, our galaxy might never have developed into its current form. One could say, black holes are the dark architects of the universe. They shape galaxies, influence the birth of stars, and may even play a role in the development of life. But how exactly? That remains one of the greatest mysteries of modern astrophysics. Black holes are the ultimate mystery of the universe. Unimaginably powerful, yet essential to cosmic order. They challenge our understanding of space and time, and there is still so much we don't know about them. Are they just giant gravitational traps, or perhaps the keys to other dimensions? What do you think? Leave your thoughts in the comments.